In this video we're going to look at a slightly different way of presenting our significance tests. We're going to conduct the significance test by calculating what is known as a p-value. And as you'll see, the steps in conducting a p-value significance test are very similar to begin with as the steps for a critical value significance test. We need to define the variables, we need to state the null hypothesis and the alternative hypothesis. We then need to describe the test statistic and give its distribution on the assumption that the null hypothesis is true. We need to state the significance level of the test and whether the test is a one-tail or two-tail test. So far everything has been the same as in the previous videos, but step 4 is the point at which we diverge from the previous videos, and in step 4 we are going to calculate what is known as the p-value for the test. And the p-value for the test is simply the probability, assuming that the null hypothesis is true, of getting a result that is at least as extreme as the observed value. Once the p-value has been calculated, we use it to give the conclusion to the test in context. Now, if the test is a one-tail test and the probability, the p-value that we've just calculated, is less than or equal to the significance level, then the decision is to accept the alternative hypothesis. If the test is a two-tail test and the probability we've just calculated, the p-value, is less than or equal to half the significance level, then the decision again is to accept the alternative hypothesis. Otherwise, the decision should be that there is insufficient evidence to reject the null hypothesis in favour of the alternative hypothesis. So we're now going to move on and look at the two examples that we've already considered using the critical region method and use the p-value method for these two examples. So let's first of all look at the example considering the production line. So in the past, 98% of the production line passed quality control. After a cost-saving change to the production line, the manager wishes to know whether there's been a reduction in the quality of the output. He suggests that a random sample of 30 items should be tested for this investigation. And we're asked to, with using a 1% significance level and by calculating a p-value, carefully state the conclusion we would make if 27 out of the sample passed quality control. So we set the significance test up to begin with in exactly the same way as before. We need to define the variables. So P is the probability that a product made after the changes is accepted by the quality control. We need to state the null hypothesis and the alternative hypothesis, which as before is P is 0.8 for the null hypothesis and P is less than 0.8 for the alternative hypothesis. The test statistic is the number of products in a random sample of 30 products taken from the production line after the changes have been made, and it's the number of products that pass quality control in that case. If the null hypothesis is true, then x is binomial, n equals 30, p equals 0.98. The significance level of the test is 1%, and it is a one-tail test rather. And we've got to calculate the p-value for the test, and that is the probability, assuming that h0 is true, so assuming the null hypothesis is true, of getting a result that is at least as extreme as the observed value. The observed value was 27. We're worried about whether x is going to be less than or equal to 27. The probability that x is less than or equal to 27 using our calculator is very easy to work out. If x has got the binomial distribution with n equals 30 and p equals 0.98, comes out to be 0.0217, and that is bigger than 1%. So we've got a one-tailed test, and the p-value is not smaller than the significance level. The p-value is not less than 1%. In this case, our conclusion should be to say that there is insufficient evidence at the 1% level to reject the null hypothesis in favour of accepting the alternative hypothesis. And putting that into context, we would be saying there is insufficient evidence to reject the hypothesis that the probability of a product made after the changes being accepted by quality control is 0.98 in favour of the hypothesis that the probability is less than 0.98. So we haven't got enough evidence to reject the null hypothesis. Moving on then to the case of the survey that we considered. We had a large survey was conducted to discover what people thought was the major threat to the future of the human race, and 73% thought that climate change was the major threat. And during the autumn of 2020, in a survey of 50 people, only 28 said that climate change was the major threat. We've got to use a 5% significance test to investigate whether this suggests that there's been a change in the proportion of people who believe that climate change is the major threat. But this time we're going to do it using a p-value calculation. So, going through the significance test, again we've got to define our variable. Let p be the probability that a person chosen randomly in 2020 says that climate change is the major threat. Our hypotheses, well, we've got the null hypothesis is that p is 0.73. The alternative hypothesis is that p is not equal to 0.73. The test statistic is the number of people who say that climate change is the major threat in a sample of 50 taken in 2020. If the null hypothesis is true, then x is binomial with n equals 50 and p equals 0.73. Again, we've got the modelling assumption to think about the fact that clearly we need the sample to be a genuine random sample. We need to state the significance level of the test. Well, we've been told to do a 5% significance test and decide whether the test is a one-tail or two-tail test. Because we're looking at whether there's been a change in the proportion of people, it's definitely a two-tail test. Okay, so now what we need to do is calculate the p-value. So, 28 is less than we expected. So what we're going to do is we're going to calculate the probability of getting a value of x that is less than or equal to 28. And that's going to be my p-value. So, using the binomial distribution with n equals 50 and p equals 0.73, we get the probability that x is less than or equal to 28 is 0.0071. So we've now got to use that p-value to give the conclusion of the test in context. Now, we've got a two-tail test. And in this case, the p-value is 0.0071, and that is less than 0.025, which is half of the significance level. Remember, if it's a two-tail test, we have to look at how the p-value compares to half of the significance level. So there is significant evidence at the 5% level to accept the hypothesis that there has been a change from 73% in the proportion of the population who believe that climate change is the major threat. Now, just as a short exercise, what I'd like you to do is find the p-value for this test if 41 people in the survey had said that climate change was the major threat. And what conclusion would you then draw? When you've done that, start the video again. There's just one more slide to see. Right, p-value tests are generally a little bit quicker than calculating the critical values. But if the investigation is to be repeated lots of times and possibly even in lots of different locations, then you'd need a statistician available at each of those different times or in each of those different locations in order to make the deductions necessary at the end of the test. Although the critical value method requires a little bit more work at the beginning to set up, it does finish with a clear decision rule, which means that people who aren't statisticians can conduct the investigation and then make appropriate conclusions without needing to refer back to the statistician who designed the investigation. And this is certainly a major advantage for investigations that may have to be repeated many times and possibly in very different geographical places. And in the next video, we're going to see that knowledge of the critical region is important if we wish to measure the likelihood of making an incorrect conclusion from our hypothesis test. It's important at this stage just to state the fact that you really do need to be able to do your hypothesis test either using a p-value or using a critical region method. Both are necessary.